Welcome back to PV Online Chemistry. Today we're going to take a look at a problem dealing with Boyle's law. Boyle's law is the relationship between pressure and volume, and he states that pressure and volume is going to remain constant. So if one of the variables changes, so will the other. So we take a look at this, and it says we have a sample of chlorine gas has a volume of 225 milliliters when its pressure is 0.965 atmospheres. And we want to find what will be the new volume if we alter the pressure to 1.139 atmospheres and our temperature remains constant. So temperature is not going to be a variable. The very first thing we're going to do is we're going to drag the givens. So we know the initial volume, so we're going to call that V1 of chlorine, and the initial volume was 225 milliliters, so we're going to go ahead and drag that. And it says when its pressure is at 0.965 atmospheres. Since the pressure and volume remain constant, it's going to be very important that you pair them up appropriately. So the volume is 225 milliliters and the pressure is 0.965 atmospheres. So those both are going to have the subscript of 1 to indicate that they're at that same time. Now, the question is, what will the volume be? So now we want to find out, what will the volume of chlorine be? So the volume of chlorine is going to be our unknown when the pressure is changed to 1.139 atmospheres. So we've identified our variables. Now we're ready to set up our relationship. Now we're going to choose the right equation in order to solve the problem. Boyle's law states that pressure times volume equals a constant. And when you say that, that means that the pressure at one condition and the volume at that same one condition is going to equal the same value. Look at this first equation right here. And while it looks very similar to pressure times volume equals constant, you'll notice that the subscripts are different. Therefore, this is not going to be the one that we want to use, and therefore you get the little X through it. Right here, this is saying that the pressure V1 equals a constant. That just means it's going to equal the same value no matter what you do. So we're going to use this one for our Boyle's law equation. The next step is going to be to rearrange the equation so that we can solve for the unknown. Now you'll notice that V2 is our unknown, so each one of these has V2 as on the left by itself. So now how are we going to rearrange this? And you'll notice that we're going to have to divide both sides by P2 to get it to get V2 by itself. Therefore, we're going to use this one. Okay, now what we have to do is we've got our equation set up the way we want it. Now we have to place our values in so we can do the calculation. So P1 had a value of 0.965 atmospheres. V1 has a value of 225 milliliters. P2 has a value of 1.139 atmospheres. And notice what's going to happen to the atmospheres. Now, since we recognize that the atmospheres is in the numerator and denominator, they're going to cancel each other out. And in doing so, the only unit we have left is milliliter, which is an appropriate unit for volume. So we're going to select that. Finally, we have to end by doing the calculation. We're going to multiply the two values in the numerator, divide it by the denominator, and when we do that, we get 190.6. Actually, you get 190.6277, but to make sure we keep it in appropriate significant figures, I'm going to round that to 191. We hit submit, and there we go. Good luck.